It's time for part 2 video in our ongoing tutorial series of LlamaIndex. This video will provide a complete beginner-friendly guide to build a retrieval augmented generation pipeline using Qdrant as the vector store, HuggingFace for open source large language models within the LlamaIndex framework. Please note that the service context from the part 1 video is now deprecated in the latest version of LlamaIndex. That's where if you have not watched our part 1 video, that is completely fine. This is the only video you need to learn retrieval augmented generation using LlamaIndex. So let's get started. If you're not aware of RAG, let's quickly dive into what is retrieval augmented generation. Large language models are great. It is able to generate a very quality response. But what if you have your own data? What if you need a large language model to refer to your database and then it should respond to that particular data? This is where we have retrieval augmented generation. Let's consider I am the user. I enter a particular query. This query, it's nothing but what is the best health tip. So I have a data set which is of a healthcare domain. And once I ask this particular query, I'm converting my query into embeddings. When it comes to deep learning or large language models, it doesn't understand text. Rather, you need to convert your text into vector representation. Once you convert your text into vector format, you look into vector database and then it performs certain search technique. It can be cosine similarity, it can be maximum marginal relevancy. Based on the search that is done in vector database, you return the relevant chunk. So why relevant chunk? Whenever you are storing data into vector database, rather than storing the entire data context, you're saving the smaller chunk of the data so that you don't end up into exceeding the context limit of large language model. So once you have the retrieved chunk, you are supposed to give this retrieved chunk to a large language model. But before that, you also need to augment your user query. This query is rather very simple. If you want to enhance this query, you need to have certain template. And this template, you have system prompt. So what does system prompt do? It assigns the role to a large language model that it needs to follow. Then you have user. So user, it's nothing but whatever I enter my query, it will be added in this particular user query. And then you have assistant. This particular template is from Microsoft Fee model. It might vary from other open source large language models as well. Mistral model has its own prompt template. Llama model has its own prompt template. That's where every open source large language model has its own prompt template. Once you have this prompt template that you have designed, you need to augment your prompt. Now, if you look at the system prompt, you're telling the large language model that it is an AI assistant. And then if you look at the user prompt, whatever the user enters, you are just appending it. In some cases, you might add few additional information. In our case, this is just a simple example to augment your prompt. Now, if you look closely, whatever retrieved chunk you have and whatever augmented prompt you have, you're giving both of them to a large language model and then it is generating the response. So this is what retrieval augmented generation looks like in a very overview terms. So in order to get started, let's build it using LlamaIndex. Alright, it's time to connect your own data with a large language model and let's build RAG. So in order to begin, we need to install few libraries. The first step is you need to install LlamaIndex and then we have three different things that you need to install. The first thing is Qdrant, which is your vector store. And the next thing is you have fast embeddings, which is used to convert your text into vector representation. And the creators of fast embeddings is also Qdrant. The next thing is you need to use an open source large language model. Since we don't want to load the model locally, we will be using HuggingFace API. There are two ways you can do it. Either you can use HuggingFace pipeline. If not, you can use HuggingFace API. We will go with HuggingFace API for this particular video series. And there is also one more library that you need to install, that is LlamaIndex readers file. So data is available in different format. It can be PPT, it can be PDF, CSV, and so on. If you want to load the content of the data, you need to have specific tool to that. And this is where we will be using the LlamaIndex tool itself so that the schema is following the particular code that we are writing. So these are the few libraries. Once you install them, make sure you click on runtime and you just use restart session. So there is a bit of dependencies issues between NumPy and few of the libraries. So it's better to run or restart your session once you write the installation step. And let's begin with our first step. So the first step is to define the large language model and embedding model. So when we are using LlamaIndex, by default, the large language model and embedding model is OpenAI. And many people don't have the access to OpenAI, so it becomes very difficult to build a RAG pipeline using closed source large language model. This is where we will focus on open source. And in order to override the default large language model, we can use something called as settings. So from LlamaIndex dot core, we will import settings. And I'll also use one more library, which is getPass, so that once I enter my API key, it's not visible to anyone. So from getPass, I'll just write import getPass. So the first step is to assign your HuggingFace token. And in order to define your HuggingFace token, I'll just write enter your access token. And once I run this cell, it will ask me to enter my API key. So what I'll do is I'll open my HuggingFace account. So I just have to enter huggingface.co. And once you click on huggingface.co, click on your profile icon. You need to create your account. And once you create your account, you just have to click on your profile icon, click on settings. Then you have access tokens. And in your access token, you just have to create the new key. And once you create your new key, just copy it. In my case, let me copy my key and I'll get back. Okay, so I've copied my API key. I will paste this API key over here. So the API key is nothing but Hugging Face access token. Once this is done, the next step is you need to override your embedding model and a large language model. So let's quickly import the statements from LlamaIndex dot embeddings dot FastEmbed. FastEmbed, I'll just import fast embeddings. And the next step is I need to import Hugging Face API as well, which is our large language model from LlamaIndex dot LLM dot Hugging Face API. I'll just import Hugging Face inference API. And once this is done, you just have to run settings dot embed model to override your embedding model. I'll just copy this fast embeddings. I'll paste it here. So by default, it will run DAAI model, which is a very small model. So as you can see, we are able to load this particular model in a format called Onyx so that it's optimized model of your existing open source embedding models. And in order to pick what embedding model you need, we have a leaderboard, and the leaderboard is called MTEB leaderboard. So what you can do is you just have to open this leaderboard and you can pick the model name. And once you pick the model name, you just have to paste it over here. And when it comes to fast embedding model, you just have few supported models. Few supported models include GTE large from NLPer. So I'll just include the model name. The NLPer GTE large. So this is one of the model name, and you have few more models from BAAI. So now that you have imported your embed model, the next thing is you need to define your LLM as well. So settings dot LLM equals to Hugging Face inference API, and I will define model name to be Mistral instruct model, which is very consistent model that I've seen. Mistral AI, Mistral 7 billion instruct. I'll use the latest one, which is 0.3. And then I have to define the token, which is the Hugging Face token. So these are the two steps that you need to do. The first step is you need to override your embedding model. The second step, you need to override the large language model. We are good to go with the second step. So the second step is to load the data. So now what we'll do is step two, load the data. And in order to load the data, we will be using simple directory reader. And in order to do that, I just have to use from LlamaIndex dot core import simple directory reader. And once you have the directory reader, you will also need something called as vector store index. So I'll just import it for time being. It will be used in the later steps. And now what you need to do is you need to upload your document within your project directory. So I'll just click on this particular directory icon. I will create a new folder. The new folder will be just data. And inside data, I will upload a document. So the document that I will use here is a PDF, and I will also attach the link of the PDF that I'm using. If in case you need a demo file, you can use the demo file. If you have your own data, then probably you can use your own data as well. All right, so I've uploaded a document within the data directory that I have. And now I'll just create a variable documents equals to simple directory reader, and you need to pass the path of your directory where you have your actual data, and then you just have to load the data. And this will load the particular data, and the format of this particular document is in the LlamaIndex schema, which is node. And next thing is you need to define your indexing. So in order to create index, you need a vector store. So the vector store in our case is Qdrant. So now what we will do is we'll define the vector store. Define the vector store. So now I'll import Qdrant client. And there are two things that you need to import now. Whenever you're using a vector database, which is an external vector database, the first thing is you need to have its own vector store. If it is Qdrant, you need to import it from the vector stores. If it is Troma, you need to do the same thing. The next thing is once you have your vector store, in order to create index, you need storage context. In our previous video in part 1, we spoke about service context and storage context. Service context is deprecated, and in order to use that service context, we have settings. So previously, in order to override your embedding model and large language model, we had service context. Now we are doing that with the help of settings. But for storage context, it is used to store your vector storage. So I'll just use from LlamaIndex dot core import storage context. And one more thing is from LlamaIndex, I need to import vector stores. From vector store, I need to use Qdrant, import Qdrant vector store. So these are the two things. And I need to define the client first. There are multiple approaches that you can use in order to define the client. One approach is you can use a localhost. In localhost, you can use Docker image where you're hosting your particular Qdrant client. The next step is either you can use in-memory. What in-memory does is you just have to provide a collection name where your vector store will be saved within your project directory. The third method is you can use a cloud service of Qdrant where you just have to provide the URL and the API key. In our case, we will use in-memory, that is to store our vector storage in a collection name within our project directory itself. So Qdrant client dot Qdrant client, and I'll just define the location. The location is memory, which is your in-memory. So now that I've defined the client, the next step is I need to define the vector store. So let me create a new cell. Vector store equals to Qdrant vector store, which you have already defined. You have already imported Qdrant vector store. Just copy it here. And then you need to pass the client. And the next thing is, since I told you, if you're using in-memory location, it is saving based on the collection name. So each collection name needs to be unique. So I'll provide equals to collection name equals to quickstart. So this will be the collection name. So as of now, you're just creating the instance of it. Later, when you define the index, you're combining everything. You're combining your data, you're combining your vector store. And since we are using embedding model, which is happening on the backend, your vector store index will take care of it. And now what you need to do is you need to define your storage context, which is very important. So storage context equals to, just copy this storage context from defaults. So by default, this storage context also is running in memory. So you need to override it with the vector store. Your vector store currently is Qdrant. You don't want to use in-memory vector store, right? You already have Qdrant vector store. So here we'll use vector store. Vector store equals to vector store. So don't confuse these terminologies. I'll probably give you a high-level overview. Qdrant client needs to have a collection name where you're saving your entire storage in memory. And when it comes to storage context, it doesn't have any inbuilt vector store. Vector store in the sense you have Qdrant, you have Chroma, you have Fias. If you have your own choice of vector database, you need to override the storage context. This is what we are doing here. We want Qdrant as our vector store. That's where we are overriding our storage context with our own vector store. So this step is done. Now what you need to do is here we have imported vector store index. So now we will perform indexing. So the step 4 is indexing. Step 4 is index your document. So now in order to index your data, we will use vector store index, vector store index from documents. And since this is one-time process, you need to provide your documents, which is your loaded data, documents, and then you need to provide the storage context as well. Storage context equals to storage context. Now this will take few seconds to index your document. If it takes more than 10 seconds or 20 seconds in order to create the indexing, probably you can use different techniques as well. Uh, Qdrant, it's a pretty advanced vector database. It provides something called as binary quantization that you can use to improve your retrieval process as well. But in our video, we just want to keep it very simple so that user can follow. Now that we have created the index, the next step is you need to generate the response. So now you have step 5, which is to generate the response. And there are few things again you need to notice here. When it comes to generating the response, we need a large language model. And we have already configured the large language model, which is the backend of your query engine. And where is this query engine coming from? The query engine is coming from index. So now you just have to define your query engine. Query engine equals to index dot as query engine. So we'll define as query engine. And if you notice, there are other functions as well. Either you can have your own chat service as well. If you look at here, you have as chat engine, then you have as query engine. And if you want your index to be acting as a retriever, you can also use as retriever. And now that we have defined our query engine, there are two functions that you can explore. The first function is dot retrieve. So what dot retrieve will do is based on the user query, you're retrieving the relevant document. Retrieve the relevant documents from the data. So this is the first step. And the second step is you can do dot query and then you can pass the user query. So what this will do is it will use a LLM and generate the response. So if you look at that particular diagram that I showed in the beginning of the video, you're passing the context, you're passing the user prompt, and then LLM will generate the response. This is what will happen in the query. So let me add bullet so that it will be simple to understand. So these are the two functions that we will currently explore. So let's define the user query. And in order to define the user query, the document that what we have added, it's a very small story. It's not more than 10 pages. Let me open this document. So as you can see, it's just 11 pages document, and there are few dialogues that is happening between 2 to 3 users. So based on that, I've already copied my user query. So let me paste it here. And the user query is what did Lupo reply to when the sun is done, the other stars will be gone too. So this is the user query. So based on this dialogue, I just want to know what a person will reply to it. So this is the user query. And now I'll use the first function, which is index dot retrieve, not index, rather it is query engine dot retrieve. So let me run context equals to query engine dot retrieve user query. And now if I print context, it will show me the nodes of whatever I have inside LlamaIndex. So this will include the metadata as well. So what is metadata? It will tell you the page label, file name of your document, and where that particular file is, creation date, and other important data as well. And if you look at text, there will be one label which is text. If you see here, you have the text. This is what you need to extract for your context. So there are two things. One is you have the metadata. Second thing is you have the text. So let me run this. First, let me check the type of it. Type context. It's a list. So we'll do a list comprehension. I need to get the context data for information in context. I need to extract info.txt. Hopefully it should not give me any error. Let's see. Okay, it's not an error. Now if I run context data, you will only find the document. That's it. All right, so this is the document. As you can see, we have only the text data, and this is what we need. That's it. And the next step is once you have the context, you can also generate the response, but you don't need to pass this context data. Rather, query engine is very intelligent. So in order to get the response, you can directly run query engine dot query and just pass the user query. The pipeline that we have created, it's pretty fast since the document is very less. It won't take much time to index your data and to generate the response. But if you are using a very large document, probably indexing might take some time. And response, it's something that you can adjustable. You can improve the response time as well. There are other large language models from Grok, which is super fast. And we have already created few tutorial videos on Grok. Probably you can check those. And there are other challenges, but all the challenges will come in the different video series. So now what we will do is we'll just print the response. So as you can see, it only took 2 seconds to generate this response. Okay, so done, right? They will muttered Lupo. So this is the response. Let's verify it. Let me open the document. And now what I'll do is I will copy this user query. I'll check where this was spelled. I'll come to this document. I'll do a search. So as you can see, Adele tells this particular dialogue, when the sun is done, the other stars will be gone too. And then you have the same dialogue. So what retrieval augmented generation will do is, it is the knowledge transfer. So whatever data you have in your knowledge base, retrieval augmented generation will pick that context using search, will give it to a large language model, and it will generate a reasonable response in a overview, this is the only thing that what RAG does, and it's pretty powerful. And now I wanted to show you how you can define your own prompt template. So before we can jump into prompt template, I want to show you something. The function name is query engine dot get prompts. So here you might be thinking that, okay, we are only using one prompt, but if you print this get prompt, you will find two different dictionaries. So if I print this, okay, so it should be get prompts, my bad. If I print this, you will see two different dictionary and both the dictionary has its own prompt. So if I print it, so let me print this. What I need to do is query engine dot get prompts. I will just print the keys. Let's see what the keys is. So you have response synthesizer text QA template, then you have response synthesizer refined template. So what response synthesizer will do is it's again a package that you have within LlamaIndex which will improve your prompt. And the text QA template, it is typically used for your retrieval augmented generation question and answer use case. And let's look at what refined template is. So what I'll do now is I'll just print query engine dot get prompts, and I'll also look into both the prompts. Let's see how the prompts are written. Let's paste this. Okay, again, it's in the Llama index format. What we can do is we can check for the particular key that we need to extract. The particular key is template. So I'll print dot template. Okay, it's an error again. Let's print this again. Okay, before template, if this is your template, you need to pass the default template. Okay, let's try this. Instead of template, let's try default template. Cool. Now you have your prompt template. What I will do is I'll just print dot template. So if you look at this particular query, you have context information is below. You have the context str. So again, the same diagram. In order to pass your data to large language model, you need to have context, you need to have user query. This is what you're doing internally. Now what we will do is we'll also look at the message template. So what you have is in your text QA template, one is you have a default template and one more is you have a chat template. So this chat template, it's nothing but the messaging. So let's check out that particular prompt. Let me print this again. And we currently refer to default template. Default template is ending here. And the next thing is you need to use conditionals. Dot conditionals. All right. In conditionals, if you notice, this is a list. And okay, let me print the zeroth list. Let's see what it is about. And now that you have looked into text QA template, you also have something called as refine template. So let's see what is inside refine template. So I'll run query engine. Probably I could have used a variable, but that is fine. This is only the experimentation that we are doing. So query engine dot get prompts. This time I'll use a refine template. You have the same thing. Here also, if you notice, one is you have a default template and one more is you have a chat template. So what I'll do is I'll check the default template. First, default template dot template. The original query is as follows. Whatever user queries that you're passing that, we have provided an entire answer. Okay, so what is happening is once you perform the query engine, you are passing the context, you are passing the query to the text QA template. Text QA template will give you the answer. This answer is passed to the refined template, which is given as existing answer. we have the opportunity to refine the existing answer only if needed with some more context below. You have the context message. Given the new context, refine the original answer to better answer the query. Okay, so this is pretty neat implementation of doing the prompt engineering for RAG, and LlamaIndex is very good at this. And now what I'm getting into is how do I override my prompt template, right? If you notice my particular slides, I told you each open source model has its own prompt template. And now we will use our own prompt template. So let me define a prompt template from LlamaIndex.core import prompt template. Now I'll define a template. So the template for Mistral model, it's something like S. You need to start with S, and then you have instant. And once this is done, you need to close it. This is it. So this is the prompt template that we need to follow. And what I'll do is I'll give the system prompt. Let me define this. All right. So I'll define the system prompt first. You you are an helpful AI assistant. Use the following pieces of context to answer the question at the end. So this is my system prompt. And now if you see, if you don't know the answer, just say you don't know. Don't try to make up an answer. And if you notice here, I'm giving context str and query str. This needs to be followed based on whatever you have here. And this was the sole purpose why I had to print this and check the prompt template. This is very important. Make sure whenever you are defining your own prompt template, you use these placeholders. So this placeholders is what you call as input variables. And where did I get these input variables? Very simple. Just print the default template. In default template, you will find those. And now that I've defined my prompt, I'll just run this. And prompt equals to prompt template. And I'll define the template. Now that your prompt template is defined, the next thing is you need to update your existing prompt in query engine. And in order to do that, just write query engine dot update prompts. And inside this, you need to pass the dictionary. Why dictionary? Because your get prompts is a dictionary. And inside this dictionary, you have two different template. And I need to override QA template. I'll just copy this and I will paste it here. And this will be updated with my new prompt. And now if I print query engine dot get prompts, if you see here, it's updated. You have this particular open source template of the Mistral model and you're able to see the difference. And I'll just remove this for time being. And now if I come back, I'll just write response equals to query engine dot query user query. And I'll just print the response. So more or less the response will be same. It won't be that much of difference. As you can see, it's much better than before. Before you had very detailed response. So if you see here, it actually copy pasted. If I come back here, if you see here, it's directly doing the knowledge transfer in previous response. And in order to refine this, I just use the template and that's it. If you look at this response, it's more simple and direct to the user query. And this is where, when it comes to open source, use their own prompt template. It's much better. And in order to get better result, this is what you need to do. So this is it from this video. We will also jump into agents starting from part 3. It's gonna be very exciting series. And in order to stay updated, do subscribe now. Thank you so much.